The lesson outcome for this video is I can calculate exponential growth. So in previous lessons, we've actually graphed exponential growth, and we found out that if you have a graph that has a certain amount and then it slowly increases and then it gets a steeper increase, etc., that we are talking about exponential growth. So the model for exponential growth is shown right here, and it's y equals a times the quantity 1 plus r raised to the t power. Now remember, exponential growth means that the function is increasing by a certain percentage. Okay, that's different than that's different than linear growth, because linear growth increases by a certain number value, a constant number value. Now we're increasing by a percentage. So the growth gets larger as it goes on. So y equals a times the quantity 1 plus r raised to the t power. We have to remember a few things about this. First of all, a represents the original amount of whatever it is that we're talking about. Original amount. Okay. Now that could mean money if we're growing money. It could mean cells if we're talking about a science lab and cells are growing. It could be whatever it is that is increasing. 1 plus r represents right here our growth factor. And a growth factor is 1 plus r, r being kind of the most important piece here, and r is your rate. Okay, so what rate are you increasing at? And that is going to be a percentage, and we're going to want to write that percentage as a decimal when we're putting it into our equation. T is time, as you might have guessed, and time means the number of years that goes by. In most example, it's years. It could be hours or minutes or seconds even, but time. Now, let's talk about time a little bit. So time down here, when t is greater than 0, when the amount of time that we're raising that growth rate or growth factor by, when it's greater than 0, like 1, 2, 3, 4, the function will give us future cost. So how much, or not necessarily cost, that's if we're talking about money, but the future values. So future cost, if we're talking about an original amount of money, if t is 3 years down the road, well, if the money is growing 3 years down the road, we're getting a future amount. All right, where on the other hand, if t is less than 0, so if it's -1, -2, -3, that would mean like -3 years ago. Now, if something is growing, that means 3 years ago it was less. Okay, it doesn't mean it's decaying, it's still growing, but we're talking about time being less. So therefore, we would be talking about our past cost or past amount that we had as this item is growing. Okay, let's try an example. You deposit $150 in a savings account that earns 5% interest compounded yearly. Find the balance in the account after 10 years. Okay, so if we write that growth equation we had, y equals a times 1 plus r, all raised, or the parentheses raised to the t power, you're going to see all of those values showed up in our example. Okay, let's take a look first at a, the original amount. Well, the original amount is, well, you deposited $150, so that's your original amount in your savings account. Second, we can see that the rate is shown in this problem, and it says in a savings account that earns 5% interest. That is the interest rate, so that will give us the number for r. And then lastly, we have t right here in our equation that we need a number for, and it says what's the balance in the account after 10 years. So 10 is our value for t. So we're going to put those values in, and we'll be able to simplify and find out what our balance is, which is going to be our y value after 10 years. Okay, so let's go ahead and write y equals a is our amount that we started with, so we'll put 150 in there, times 1 plus the rate. Now this is where we need to be careful. The rate is written right here as a percentage, but we need to write it into our equation as a decimal value. Remember that 5% means 5 out of 100. That's what percent means. And if you did 5 divided by 100, you'd find out that the decimal is 0.05. The other thing you might remember is that in a percent, if you move the decimal over 2 places, so currently the decimal in 5 is right here, we move it 2 places to the left, which means we need to put a 0 right here, so 0.05. A mistake that's often made with this is people put in 0.5, but 0.5 is 50%. So we're going to put 0.05 right here for our rate, and we need to raise that now to the t power, which in this case is 10 years. Okay, so on most calculators you'd be able to just go ahead and compute this right now by multiplying 150 times, and make sure you use your parentheses, 1 plus 0.05, and then close the parenthesis and then raise that to the 10th power. Okay, so we'll go ahead and try that on our calculators. Okay, so when we compute that, we should get 244.33419 is what my calculator says. Since this is money, we should go ahead and round this to the nearest penny, which would be 33. So if you deposit that $150 in an account with 5% interest, the balance in the account after 10 years will be $244.33. Let's try one more example. John bought a vintage car in 1984 when its value was $11,000. The value of the car increased at a rate of 6.8% per year. Prince bought that same car at an auction in 2004. What was the approximate value of the car at the time of the auction? All right, so let's start by writing our equation. Y equals, go ahead and put A as the red value here, times 1 plus the rate I'll raise to the t power. Okay. So y equals the original amount of the car. Now, we're not talking about the original amount here that was when the car was first made. Now, this is a vintage car, it says. Vintage means an old, probably a classic or a collector's car. So in 1984, that's not when that car was created, but we don't have that original amount. We just know that the car increased at a rate of 6.8% per year from when John bought it. So this is our original amount in this problem. So $11,000 is the original amount there. And we have 1 plus the rate. Now, once again, we have to be careful with the rate. The rate is 6.8%. And again, if we move that decimal 2 places to the left, we're going to need to fill in a 0 here. So it's going to be 0.068 is 6.8%. So 0.068. And all raised to the t. Now we need to know how many years, right here goes, how many years it has been. Well, from 1984 to 2004 is 20 years. So we're going to go ahead and put 20 years in here. Once again, we can we can use our calculator to compute this value. And when we compute this, we will get 41,003.19882. Now, that's going to round to 20 for 20 cents. So, how much is the car worth at the auction? Well, $41,003.20. Remember, as you're reading word problems, one of the best things you can do for yourself is look for those key pieces of information. Notice the $11,000, the original amount there, our rate, and go ahead and use colors too if it helps you to get things pointed out and where they then go, like the percentage would go there for the rate and the original amount there, things like that. So go ahead and use underlining or circling or putting rectangles around things that are key pieces of information.